Hey guys, welcome to my class. Today I will talk about iodoform reactions and Tischenko reactions. So, what kind of reactions are there in these two kinds of reactions, and I will give some tricks and also I will show the mechanism of the two reactions. So, at first I will go with iodoform reaction. So, let's see. In this reaction, organic compound having keto-methyl group, when it reacts with iodine and in presence of a base, iodoform yellow colored precipitate is there, and sodium sulfur carboxylic acid is produced. For example, CH3CO, suppose here is H, example 1. So when it reacts with I2 plus NaOH, we will have CHI3 plus HC double O Na. So this methyl group will convert into this iodoform, which is yellow colored, and this one will convert into this group will convert into corresponding carboxylic salt. Now let's see the mechanism. Hydrogen, 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 CO, OH. So base, you have base. So this OH minus will take H plus. This is acidic hydrogen because of this keto-methyl group. So there will be a tautomerism. So we have HC, H double bond C, O negative, and one hydrogen. Now when it come back, it will go and it will take iodine, and this iodine will goes out, and you will have HC, H, here is iodine, here is C double bond O, H. So if we give again OH minus and I2, we will have this one will goes, this one, this bond will goes at here, and this one will goes, and C H, here is I double bond C O negative and hydrogen. So again it will take another iodine. Again it will take another iodine. In this way, this compound will, these molecules will, in this way, this molecule will have two iodine. Again, if we react with OH minus and I2, then another iodine molecules will come here. So we have II and CHO. Now OH minus will attack at this carbonyl group. This one will goes out, and we will have CII negatively charged plus HOOH, and this is acidic hydrogen, so it will goes, and this no longer will take H plus, and the product will be CHI3, one hydrogen and 3 methyl groups. This is iodoform plus HCO negative, and there will be sodium plus from OH minus. It will come from NOH. This plus. So this is the sodium salt of carboxylic acids, and this is the iodoform. So this is the mechanisms how the keto-methyl group converts into this iodoform compound. Now I am sure this is another examples where this methyl group converts into this iodoform, and this part will convert into this carboxylate salt CH3CO, and there will be ONA. It will come from here. Okay, so this is another example. Let's see. CH3CO CH2 CH3. if it reacts with NaOH and I2, then this methyl group will convert into CHI3 plus, and this portion will convert into corresponding carboxylate salt. Okay, so these are some examples where organic compound containing carbonyl group converts into iodoform, which produce iodoform, which is yellow in color. Yellow in color. So by this reaction, we can identify whether any compound contains ketomethyl group or not. If we have a yellow precipitate in presence of iodine and NaOH, then compound contains ketomethyl group. So this test, iodoform test, can be used to identify whether any compound contains ketomethyl group or not. Now, some alcohols also gives this iodoform reaction. For example, CH3CH2OH. Look at the structure. There is no ketomethyl group, but still this type of compound gives iodoform test. So how? When it reacts with iodine and NaOH, your product will be CH3 plus CHI3 plus is COO Na. Now I am showing the mechanism how actually this group convert into this compound converts into this methyl group. OH. We have base, so this is acidic hydrogens because of its electronegativity. This OH will take this S plus and this bonded electron will come here and it will goes and it will go to make bond with iodine. Okay, now CH3CH double bond O plus HI. Okay, so this alcohol group converts into this ketomethyl aldehyde group. Okay, now this one, when it reacts with NaOH, it will convert into this product. So on reaction with iodine and sodium hydroxides, this aldehyde group converts oxygen. When this alcohol reacts with iodine and sodium hydroxides, this alcohol oxidizes into corresponding aldehyde compound. As this aldehyde compound contains ketomethyl group, so it will participate iodoform reaction. Okay, now let's see other examples of alcohols. CH3COH, this is methanol. So when you react with iodine and NaOH, at first it will oxidize into ACOH. Here, this aldehyde do not have any ketomethyl group, so it will not give iodoform reaction. Iodoform reaction will not give. Again, CH3CH2OH, when it reacts with iodine and NaOH, at first this one will convert into corresponding aldehyde and it has a ketomethyl group, so it will give iodoform reaction. It will give iodoform reaction. Again, CH3CHOH, CH3, this will oxidize into CH3COCH3. This group, this alcohol group will convert into keto group, so there is a ketomethyl group, so it will give iodoform reaction. Again, CH3CH2CH2OH, here when it oxidizes, it will produce CH3CH2CHO. Here there is no ketomethyl group, no keto methyl group. As it does not have any keto methyl group, so it will not participate iodoform reactions. Again, CH3CHOH CH2 CH3. This group will oxidize and it will convert into CH3CO CH3. So it contains keto methyl group. So it will give iodoform reaction. So from these reactions, we can conclude what kind of alcohols will undergoes iodoform reactions and which one will not. Now between these two compounds, this is benzaldehyde, this is acetophenone. This compound do not have any keto-methyl group. This contains keto-methyl group, so it will give iodoform reaction. It does not give iodoform reaction. So what will be the product in these reactions? In this reaction, the product will be this methyl group will convert into CH(I3) and this one will convert into corresponding carboxylic salt COONA. Now I will talk about Tischenko. Tischenko reactions. In this reaction, aldehyde compounds, when it reacts with aluminum triethoxide, this aldehyde compound converts into ester. For example, CH3CHO, when it reacts with OETO3, aluminum triethoxide, this aldehyde compound will convert into CH3COO CH2 CH3. Look at the structure here. How many carbon? Look at the structure here. Look at the structure here. 2 carbon is there, so there is 2 carbon and here is also 2 carbon. Again, so how many carbon is there? 3 carbon. So I will write 3 carbon. There will be keto group and here will be oxygen. So 3 carbon, I have written 3 carbon. Now here there will be also 3 carbon and I will balance them by adding hydrogen. So this is the way how to write the product of Tischenko reactions in a simplest way. There will be ester group and I will write number of carbon here and number of carbon here will depends on the structure of this aldehyde compound. Now what is the mechanisms how this group converts into this ester group? This aluminum contains 6 electrons, so it does not fulfill its octet, so this lone pair will take and CH3C double bond O Al O E T whole 3, here will be negative, here will be positive, and there is hydrogen. Now another aldehyde molecules, this lone pair from another aldehyde molecules, the lone pair of oxygen will attack at this carbon and this one will goes. CH3CHO negatively charged, aluminum OET O3, no negatively charged will be there, it will be neutral, and here's O double bond C, here is hydrogen, here is CH3 group. Now this bond will come and this hydrogen will shift towards this carbon and this is having positively charged, so it will neutralize and our product will be CH3 C double bond. This methyl group, this keto group and this oxygen and this CH2, CH2, this CH3. So this is the mechanism how aldehyde group converts into how aldehyde group converts into ester. This is the point. Okay, now look at another examples. How many? Here is 4 carbon. Okay, so I will write 4 carbon at here, and this one will be ester group. This one will be ester group, and in this side there will be also a group having 4 carbon. Now I will just balance it by adding hydrogen. This is the product of these reactions. Okay, ALOET. So this is the reactions by which we can convert aldehyde to corresponding ester in a one step. We can do these reactions in many ways, in several steps. Like we can convert it into corresponding acids. We can oxidize and it will convert into CH2, COOH. Now, if you add alcohol, CH2, 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 CH3, there will be elimination of water, and you will have this kind of structure. So we can convert this aldehyde group, this aldehyde compound into ester by esterification reaction also. But here there are so many steps and we need to add this reagent extra, and Tischenko reactions. Then if we use this aluminum triethoxide, then this aldehyde group converts into ester in a single step. So this is the importance of these reactions. We can convert aldehyde to ester in one step reaction. Okay, thank you very much for watching, and if you have any doubt, please mention in the comment box. I will see later on. So once again, thank you for watching, and please subscribe my channel, and remaining name reactions I will do in the next lectures.